For millennia, wood has been humanity's silent companion. It's present in the homes we live in, the tables we sit at, and the bridges that connect our shores. But have you ever wondered, where did those smooth, square planks first originate? Today, join Mr. Tech News on a special journey to the modern sawmills of America, where millions of planks are produced every single day. For millennia, wood has been humanity's silent companion. It's present in the homes we live in, the tables we sit at, and the bridges that connect our shores. But have you ever wondered, where did those smooth, square planks first originate? Today, join Mr. Tech News on a special journey to the modern sawmills of America, where millions of planks are produced every single day. Everything begins with the harvesting process. There was a time when the prosperity of the American lumber industry was tied to severe waste. More than 70% of the value of each tree was abandoned, left to rot, or even became fuel for wildfires. That was the price paid for a country developing too quickly. Today, everything has changed. Sustainability is no longer an option. It's a requirement. With advanced technology, e-felled materials are utilized to the maximum extent. This is more than just a technical step. It's a commitment to ethics and responsibility, an act of preserving our legacy for future generations. Now let's return to the tree felling process. First, the logger creates a V-shaped cut near the base of the tree. This acts as a directional arrow, determining where the tree will fall and preventing unwanted splits. Next is the horizontal cut, known as the back cut. In many cases, wedges are cleverly inserted here to both guide the trunk's descent and keep the saw blade from binding. Finally, the logger intentionally leaves a small, uncut section of wood called the hinge. This acts as a pivot point, allowing the tree to fall in a controlled and predictable manner. This truly is a master skill, where raw strength and mathematical precision intersect. Once the tree is felled, the arduous journey of the logs truly begins. Different transportation methods are used, depending on the terrain, distance, and available resources. Cable systems. In steep, mountainous, or rugged areas, a cable system is the optimal solution. Steel cables are secured to the logs and pulled by powerful winches or cranes, allowing the timber to travel safely over steep slopes and rough ground, where conventional vehicles can't access. Specialized skidders. When the terrain is less rugged, a specialized machine called a skidder is deployed. Using powerful grapples or winch cables, they firmly drag the logs across the ground. This is an efficient and flexible option for consolidating timber in areas with moderate slopes. Water transport. In areas blessed with rivers and waterways, logs can be floated individually or assembled into rafts to move downstream to a collection point. This is a centuries-old traditional method that saves costs and allows for the transport of large volumes over long distances. Road transport. If the wood is harvested near easily accessible areas, trucks and trailers become the primary method. This allows for efficient transport over long distances and access to various destinations, such as the sawmill or processing facility. Our haul today is heading to Columns Lumber Products in South Carolina, one of the most advanced family-owned sawmills for southern yellow pine in the United States. Every truck that arrives at the company gate must pass through the scale. The truck is weighed once when fully loaded, and then weighed a second time after it's empty and unloaded. The difference between the two weighings reveals the exact amount of wood delivered, usually around 26 tons per haul. The logs are then offloaded by a crane and either taken to the log yard or placed directly onto the infeed deck. The log yard acts as a reserve, helping the production line run steadily even if log trucks are delayed. The crane operator rotates the timber so that the older logs are processed first, and when the infeed deck runs low, logs can be transferred directly from the truck onto the line. Leaving the infeed deck, the massive logs move into the debarker. In the blink of an eye, the rotating steel knife ring strips away the rough outer layer. This seemingly simple step plays a vital role. Without debarking, dirt, gravel, or even small metal fragments hidden inside could damage the entire line downstream. The bark is not wasted afterwards. It's collected, loaded onto trucks, and used as fuel for the boiler or as decorative landscaping mulch. In this way, even the byproducts have value, true to the modern sawmill's spirit of nothing goes to waste. Once the outer layer is removed, the bare log passes through a high-speed 3D laser scanner. A beam of light flashes, and the entire log is digitized into a complete model. Sophisticated algorithms immediately analyze its curvature, shape, and defects to calculate the most optimal cutting solution. Based on this scan, the wood can be cut into smaller segments, or if it meets the standards, it will be milled into utility poles, a higher value product than dimensional lumber. From here, the logs can follow one of two paths, to the DLI twin saw or the carriage saw. Let's follow the carriage saw first. For massive logs, often those exceeding 1 meter in diameter, the carriage saw is the only option. This is one of the oldest technologies in the mill, but it's been fully modernized. The carriage moves the log past the upright band saw, slicing off thin planks according to the cutting pattern established by the laser scanner. Afterward, the rough-cut lumber is transferred to the resaw, where smaller blades continue the refinement process, cutting smaller planks. Interestingly, the resaw is the only machine not equipped with laser optimization. Instead, it relies entirely on mechanical feed and human operator oversight, a reminder that not every stage can be fully automated. For medium and smaller logs, speed is the top priority. The timber passes through the DLI and reducer twin. Once the computer has calculated the optimal positioning, high-power cutter heads simultaneously shave away bark and excess wood from opposite sides, transforming the round log into a squared cant. Remarkably, the removed wood is immediately converted into commercial wood chips, ensuring 100% material utilization and maximizing profit from the very first cuts. From this rough cant, the process advances to a breakthrough stage, curve sawing. This marks a departure from old industrial thinking. Traditional methods forced curved logs into straight cuts, wasting material and producing shorter, lower quality boards. Curve sawing, however, takes a different path. It follows the rules of nature. Based on precise data from the scanner, flexible saw blades will cut close the natural curvature of the log with exact fidelity. The result is a double victory, both economic and technical. Respecting the wood's natural form produces longer boards, significantly increases overall yield, and minimizes warping or cracking during the drying process. Here, mechanical precision joins ecological philosophy to deliver maximum efficiency. After the primary cuts, the boards still bear curved, rough edges. The edger takes them in and removes the excess, leaving sharp, parallel lines. The trimmed wood isn't wasted. It's ground into chips, bound for the paper industry or biomass energy. Next, the straight-edged boards move on to the trimmer. If edging is the step that shapes the form, trimming is the step that defines the destiny. This system is lined with dozens of saw blades, spaced 2 feet apart. As each board moves forward, only the necessary blades rise to cut it cleanly into standard dimensions. If a plank doesn't meet the requirements, it is immediately diverted from the main line and returned for reprocessing. No faulty product is allowed to pass. That is the unshakable principle of the sawmill. The arduous journey isn't over yet. Once formed, the lumber must face its greatest enemy, moisture. To combat warping and checking, an automated system sorts and stacks the planks, then inserts small stickers to create air gaps for proper air circulation. The entire lumber stack is then transferred into the industrial drying oven, or kiln. This is a sophisticated scientific process that lowers the moisture content to the standard 10 to 15% to ensure the wood's stability and durability. Only when completely dry can the wood fulfill its promise of quality. Leaving the kiln, the lumber moves into the planer mill. High-speed knives smooth all 4 sides, resulting in a polished surface and precise dimensions, transforming the rough material into a finished commercial product. Finally, the finished planks are gathered into bundles, secured tightly with steel or plastic banding, and wrapped in a protective cover to ensure safety during transit. Every plank bears a grade stamp. This is the assurance of quality, clearly indicating the wood species, strength rating, and the producer's identity, acting as a solid commitment to every customer. Each bundle of lumber is now loaded onto rail cars and trucks, but beginning a new journey, leaving the United States and traveling to structures and homes across the world. Beyond planks, the lumber industry is also transforming to embrace a new philosophy: zero waste. Advanced production facilities, like Columns Lumber, are leading the way in reusing and innovating all residual materials, transforming waste into valuable resources and thereby minimizing environmental impact. Wood pellets. Small wood fragments that are too tiny for traditional production are compressed into pellets, serving as a sustainable biomass energy source to replace fossil fuels in heating and power generation systems. Wood residue can be ground into mulch for landscaping and gardening. Mulch retains soil moisture, suppresses weed growth, and adds aesthetic value to green spaces. Sawdust. This common byproduct is utilized to be compressed into charcoal briquettes, an eco-friendly fuel alternative to traditional charcoal, or used as animal bedding, providing dryness and comfort for livestock. This isn't just a cost-saving solution. It's a demonstration of resource respect and a strong commitment to sustainable forestry. And so, we've completed a truly unique journey. This isn't just a story about steel and lumber. It's a story about human ingenuity, the ability to create modern systems that ensure a long-term supply, not just for today, but for generations to come. Columns Lumber Products is a living testament to that capability. The older generations once sharpened saw blades by hand. Today, their descendants calibrate lasers and operate automated systems. But one spirit endures throughout: respecting the wood, Shaktitu utilizing it fully, and giving it a new life cycle. The boards leaving the mill are more than construction materials. They are the crystallization of an entire journey, where sophisticated technology meets the raw power of nature. Next time you touch the roof of a house, walk across a bridge, or admire a wooden structure, remember this adventure: the incredible transformation of a simple log into the very foundation that builds the world around us. Thank you for watching until the end. If you also enjoy videos like this, please hit the like button, share, and subscribe to the channel so you don't miss any of our exciting upcoming stories. This is Mr. Tech News, and we'll see you next time.